All right, we are going to be starting chapter 4, uh, which is dealing with reciprocal functions and rational functions. A lot of fractions here, so a lot of good stuff here as we kind of move forward. Hope you all had a good break. But the first section is inverse variation and the reciprocal function. Okay, so we're going to look at this, kind of give you this full screen here on how to do this, and then I'm going to show some examples. Okay, so we're going to talk through this example. The first thing that you're going to be asked is to identify inverse variation. So how do you determine if a relationship represents inverse variation? We're going to multiply the x times the y, and if these values are the same, then it is inverse x in variation. So 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. 4 times 3 is 12. So right here we have all of these values the same, so we can say that this set of data represents inverse variation. Okay, what is inverse variation? It's a relationship between two variables such that as one variable increases, the other decreases proportionally. Proportionally is the key word there. We're going to be dealing with a fraction here. Okay, so next example is just, hey, is this inverse variation? So if I look at these two examples right here, again, I'm asking you to multiply x times y, and x times y is 20, 34, 14 times 3 is 42. Sorry. Is 42. 4 times 11 is 44. 4 times 8 is 40. And 6 times 5 is 30. So we see these clearly are not the same. So we would say this is not inverse variation. Okay. Here, if I multiply through, I got 1 times 25.5 is 25.5. 2 times 12.75, and I'm just using a calculator here, is 25.5. 3 times 8.5 is 25.5. 5 times 5.1 is 25.5. 25.5 and 25.5. So as you can see, these are all the same. So we would say, yes, this is inverse variation. Okay. So now what do we do with this is we're going to take a look at what the actual formula looks like. So this is really important. The one thing that we have to look at is inverse variation. When we're talking about a constant of variation, when I write the problem out like this k is my constant of variation. Okay. So what's another way that we could write that as? X times y equals k. So these two formulas are the formulas we've got to be familiar with and understand how we found the constant of variation. It's what we get when we multiply x and y together. Okay. So if we take a look at an example, says in an inverse variation, x equals 10, y equals 3. Write an equation to represent the inverse variation, then find the value of y when x equals -6. So the very first thing that we need to do here is we're going to write down the formula. Y equals k times x. So we're going to find k. Okay, so I'm going to plug in y and plug in x. Okay, so how would I solve this problem? Multiply both sides by 10. I get 30 is equal to k. So right now I have k equals 30. So I'm going to go back to the problem that I wrote down, and I'm going to write the equation. So this right here is the inverse variation equation. Okay, the equation right here is y equals 30 over x. 30 is my constant of variation. So now I want you to find the value of y when x is 6. We just simply go y equals 30 over -6, and that would be a -5. So again, you kind of got to go through that, and this is blocked off here on your notes here, but this gives, if you didn't understand me going through these two steps right here, then this shows how the book does it. So you can move that when I share the notes with you. But in the video, I wanted to make sure I showed you the first, write down the equation, find k, and then plug in k, the value for x, and k to find y. So if we look at another example of this, it says an inverse variation, x equals 6, y equals 3. I need to first find k, right? So there's two ways you can do this. I did it this way. I did y equals k over x. I plugged in 1/2 for y, k over 6. Okay. And then you can solve this 4k however you want. I'm going to multiply both sides by 6. This gives me 6 over 2 equals k, which is 3. Okay. So k equals 3. So then I'm going to write out the equation y equals 3 over x. I'm going to take what x is equal to. So this is the equation. So this is the first one. This is part A right here. That's what they want as the equation. Okay. And then I'm going to take 15 and plug it in. So I have y equals 3 over 15. I'm going to reduce that and I would get y equals 1 over 5. That would be the answer to part B. So here's part A. Here's part B. I think this stuff is really simple as you kind of get the hang of it. Okay. So the next thing we're going to look at is the reciprocal function in the graph. And again, I kind of put this up here to let you know all of these things, but there's some really important factors to this problem right here. This is called the reciprocal function. Um, and it's the function y equals 1 over x. Okay, so this would be the most parent basic function when I have y equals x. First thing I want to make sure I mention is y, when I plug in 0 for x, is this undefined. And that's because we can't have 0 in the denominator of a fraction, right? So anytime I plug in 0 for the reciprocal function, it's going to be undefined, okay? But then as I start plugging in values, you notice these two branches of this graph kind of ride along the y-axis and the x-axis. Same thing here, kind of ride along the y-axis and the x-axis. Well, those are called asymptotes, okay? So we have what are called asymptotes for this graph, okay? So we have a vertical asymptote, which is just that. It's a vertical line. The graph approaches but never touches. And again, why do we have that right here? Because when I plug in 0 here, it's undefined. Okay, so that's a vertical asymptote. And then we have a horizontal asymptote, which, you guessed it, is a horizontal line. The graph approaches but never touches. Okay. Okay. So why is there a horizontal asymptote here for this graph? Well, think about it. I'm never going to get the value of 0 here. No matter what number I plug in for x, it won't ever equal 0 because I can't plug in 0. So these have two really important points here that are called asymptotes, a vertical asymptote and a horizontal asymptote. If you look at the domain is all real numbers such that x can't equal 0, and the range is all real numbers such that y equals 0 because of this fact right here. When I plug in 0, it doesn't work. Okay, and then if I put a number here, it's just going to kind of expand the graph. When I ask you to graph something in your homework, just plug it into Desmos and take a look at the picture. A lot of times we're looking to see what quadrant the branches are in. In this one, when it gives you a multiple choice, just look where the branches are. And then if I asked you for specific points, you would be able to find those by using Desmos and the table feature. Okay, so now we get a little bit more difficult. So I want to talk about this slide right here. There's not many questions on your homework today on this, but we will be looking at this over the next couple of days. So if I give you a problem that looks like this, we should be familiar with K and H. Okay. Well, this H is going to be my horizontal asymptote. That is not how you spell horizontal. There you go. Okay, my horizontal asymptote. What are you doing here? Come on. There we go. Okay, my horizontal asymptote, and it's always the opposite. So what do I mean by that? If this was a -5, the horizontal asymptote would be at 5. Okay, and my K is my vertical. Hold on, I think I just said that backwards. K is my, yeah, I got this wrong. Hold on a second. Good catch. Okay. It is still the opposite, but this is, sorry, this is my, H is my vertical asymptote. This is my vertical asymptote, and this is my horizontal asymptote. Okay. So again, if I give you a problem like this +2, I'm going up 2, but this is where my horizontal asymptote is. That's why I got confused there for a second. I go up 2, but I draw my horizontal asymptote. This -3 is my vertical asymptote. So again, H is always the vertical asymptote, and it's the opposite. Okay. So now if you take a look at the way that they wrote the domain out. The domain deals with this H right here. It's all real numbers except the value that makes the denominator 0, which would be 3. And then the range is all of the Y values except for, so these are linked right here. My K deals with the range, that's the value it can equal, and the domain is my H. Okay, so let's take a look at an example of that. Again, vertical asymptote, horizontal asymptote. So my vertical asymptote is the opposite of H. Okay. H is this value right here. So I'm going to have a vertical asymptote at x equals -2. My horizontal asymptote is my K value, which is -4. It would be y equals -4. So if I have to graph this, and again, you're going to do this on Desmos, but I know that at -2, there's a vertical asymptote, and at -4, there's a horizontal asymptote. Those branches are going to be somewhere in here when I graph this. Okay. So what would the domain be? Again, the domain always goes with my vertical asymptote. So if we look how we wrote that, x such that x cannot equal -2, there's my domain. And then the range goes with my k value, and that's the y such that y cannot equal -4. Okay. So not many questions about this on your homework tonight, but there will be in the next couple days. And here's kind of just a summary. Again, I'm going to share the PowerPoint with you so you guys can look at this. And kind of go from there. So give the homework a shot. It's only 7 questions, mostly over the inverse variation stuff.